All right, so as you guys know that our first unit in grade 11 is quadratics, okay? But in particular, we're going to be talking about quadratics in vertex form. Okay, so I'll talk about the different kinds of quadratic as we go through the semester. Okay, so you're going to hear me say quadratics in vertex form, standard form, factored form. I'll be talking about these different forms as we go through the semester. Now, what does quadratic represent? What does quadratic mean? Quadratic. Degree what? Degree 2. Okay? So quadratic would be y equals x squared. Okay? So whenever you see that square, that 2 on the top of the letter, that means it's quadratic. Okay? Linear function would be y equals x, right? Where there's no be degree 1. This is called linear. Okay? This is called quadratic. So this would be representing quadratic because it's degree 2, right? While this is linear because it's degree 1. You see the difference? So anywhere where you see a degree 2, so to the power of 2, you know that we're talking about quadratic functions. Okay? Now, does any of you know what shape would a quadratic function, so if I'm going to graph it, what would be the shape of that quadratic function? That's right. So for a quadratic function, the shape is going to be either like this, where it looks like a U, right? Or it could be an upside down U, like a hill, right? So this represents quadratic functions, okay? We call this a parabola. Okay, that's the name of it. We'll talk more about the parabola in a bit, or maybe tomorrow. Okay? Just so you know that today we're going to look at two different functions. We're going to look at the linear function and see how that looks like. We're going to look at quadratic function and see the difference between the two. Okay? That's what the lesson of today is going to be. So let's start our lesson. So the distance traveled by a boy on a bike is modeled by the equation y equals 3x. So the equation is y equals 3x. If you're looking at the equation, can you tell me from the equation if it is linear or quadratic? Linear. Why? No degree on the x, right? It's a degree 1, right, which we don't write down, right? So this is why I know it's linear, because if technically I can put a 1 here, I don't have to. If I don't put it, it's the same thing, right? So I know it's linear by looking at the equation because it's degree 1. Okay? So if I give you an equation, you should be able to tell me if it's linear or quadratic just by looking at the equation. Now we're going to see what happens if I have them in a table of value. Okay? So in a table of value, you have two things. You have the x values and the y values. Okay? So this would be your x values, and then here we have the equations. So here's your equation, which I just gave you this equation. I gave it to you. I told you that the equation is y equals 3x, right? And I gave you the x values. Okay? I told you I want you to find the values of y when x equals 0, when x equals 1, when x equals 2, and so on and so forth. Right? If I don't give you these x values, you get to choose them. They're any value that you like to pick. Usually, I give them to you. Okay? But if I don't, you get to pick these x values. Now, what do we do in the table of value? We take the x value and we plug it in for x, right? So what happened here is I have 3 times x. So it's 3 times 0. Right? What's 3 times 0? 0. So that gives me the y value. My x is 0, my y is 0. Okay? This is already filled out for you, but then for the next ones, we're going to have to fill it out together. Okay? If x is 1, then I have 3 times 1. What's 3 times 1? 3. So when my x is 1, my y is 3. Are we okay with this? Okay, if x is 2, then it's 3 times 2, which gives me 6. So when x is 2, y is 6. When x is 3, y is 9. When x is 4, y is 12. Okay? So technically, the table of value is this. So this is your table of value, where you have x in one column, y in the other column. Now, in a table of value, for me to be able to know if it's linear or quadratic from a table of value, I have to do something that's called the first difference. Okay? So this will be added to the table of value. This is for me to test if it's linear. So what happened when I do the first difference? What does difference mean as a math operation? What's difference? Minus, right? First difference, that means you're taking the first subtraction. So you're subtracting, okay? We call it the first because we can do the second difference if we have to, okay? That's why it's called the first difference. So to do the first difference, you take your y values and you subtract them from each other, okay? So what I do is I take the second y value and I subtract the first y value from it. So I do 3 take away 0. Okay? So 3 take away 0 is 3. Okay? Then for the next step, I do 6 take away 3. Because I always have to take the lower y value, subtract the higher y value from it. The one above it. So it's 6 take away 3. That's another 3 here. Okay? What will be my next? 9 minus 6. Right? Remember, it's the lower minus the one that's above it. Okay? So 9 take away 6, that gives me 3. Then 12 minus 9, that gives me also 3. What did you notice about the first difference? What's the first difference for the first one? 3. Second one? 3, 3, 3. They're all 3. Right? If they're all the same number, if your first difference is constant, we call it, that tells me it's a linear function. This is one of the rules about linear function, is when you do the first difference, it's going to be constant. Okay? So if I have a table of value and I don't know anything else, if I do my first difference, I will know if it's linear or not by doing the first difference. Okay? So I can state here that it's linear, and I know that because the first difference is constant. Does that make sense to you? Now, once I figure out that the first difference is constant, I don't need to go to the second difference. I don't have to do the second difference. But you'll see in other cases that if the first difference is not constant, then I have to go to the second difference, and that means something totally other than linear. It won't be linear anymore. So far, if we look at the equation, we know it's linear because it's degree 1. If I look at the table of values and I do the first difference, The first difference is going to be constant if it's linear. Now, how would a linear function look like on a graph? Straight line, right? So let's see if that's going to look like a straight line. So if I'm going to graph this, do you guys remember how to graph points? So my first point is 0, 0. X is 0, y is 0. Where would that be located on my graph? At the origin. Right? So this is where my 0, 0 is. What will be my second point? 1, 3. Right? Remember, x, y. Okay? So 1, 3. So 1 on the x-axis, and then where's the 3? Up 3, right? So my next point is going to be right here. So you locate your x-axis first, then you go to your y value, okay? This is where my 1, 3 point is. How about my third point? Where is it? 2, 2, 6, right? So 2, and I have to go up to the 6, so it's going to be about here. And then 3, 9, so again 3 all the way to the 9. I can't fit the last point, but that's fine. I can probably draw a line that passes through these points. Does this look like a straight line for you? Yes, right? You see that the points, now my graph is not the best because I don't have the accurate measurements, right? But they do follow a linear path, okay? So we know that this is a straight line. Because it's a linear function. And linear functions, they're going to have a straight line. Are we okay with this? I'm going to give you time to graph this.